All right, guys. Here we go. We're back at it. I'm going to do this. I like this better because it makes more sense to me. So today we're dealing with limits, but specifically limits of trig functions. And they display some properties that help make it helpful. So if you were to take the sine of x over x, let's say, and if you plug in 0, you'd get undefined. If you tried to factor it, it wouldn't work, and so the only way to figure it out is to graph it. So if you graph it, it'll look like this, and you can see as it approaches 0 from the left and the right, you end up at 1. The same thing here. If I just use the value of x right here, and I plug in 0, the sine of 0 is 0, it gives me undefined again. I can't factor it, but if I plug it into a calculator, I get something that looks like this. As I approach from the left and the right, I end up with 1, a value of 1. And so we work with cosine. Cosine's a little different. If I plug in my x value here, I get undefined. It's not factorable, so if I graph it, moving from the left, moving from the right, I get a value of 0. So why is that important? Well, then what you can do from here is when you get these problems, you can manipulate them algebraically to create these properties so you can insert these values into those properties. And so we're just going to tackle some examples of what I'm talking about. So our first example is this. So we're going from the limit as x approaches 0 of the sine, make sure to get this right, there we go, sine of 3x over x. So that's our function. So we're close. Look. So here's the thing. This box, it has to match. So if this has an x in it, that has to have an x in it. If this has a 5x in it, this has a 5x in it. So we've got to make the boxes match. So if I'm going to look at this piece, I have 3x in the box and just an x in the box. So here's my question for you. What do I have to add down here to make this thing look the same in the boxes? So if we keep working with this, if the limit as x approaches 0, don't know why I changed colors, of the sine of 3x, over x times what's missing? 3 over 3. I'm allowed to multiply by 3 over 3 because it is just the value of 1. So I didn't change anything. So now if we clean this up a little bit, and we're going to rewrite this, I'll go back to blue again, the limit of x as x approaches 0 of sine of 3x, here's my x, but if now I'm going to move this bottom 3 into here. I'm going to leave this other one out here. Still okay. Still 3 divided by 3 is 1. I didn't change anything. But what we notice is this represents the same thing as this. The boxes are the same. The boxes are the same. So the sine of 3x over 3x, due to properties of trig functions, is always going to be 1. So therefore, this limit is 1 times 3, which means it is 3. So the limit as x approaches 0 of the sine of 3x over x equals 3. All right? And you have to show your math algebraically. All right, so let's try a different one here. I got 3 examples for you guys today. Let's see here. So we've got the limit as x approaches 0 of 1 minus cosine Yep, all over x. So what are we missing? No sine and sine, so we're down here with cosine. What are we missing? We are missing the seven on the bottom. So I'm going to do this one a little differently. I'm going to add the 7 down here, but I got to make sure that I'm adding a 7 up top, because what I do to the bottom I have to do to the top, so I don't change the function at all. Remember, the only thing you can do to an equation without changing it is multiplying it by 1. 7 divided by 7 is 1, so I can do that. All right, so I have the box of 7x right here. I have 7x here. I have 1 minus. So when I create that type of function, what do I get? I get 0. So that means it's 0 times 7. So my answer, the limit as x approaches 0 of 1 cosine 7x of x is equal to 0. All right. So that's our second example. Well, the first part of calculus, the way we have it structured, you guys are just going to be doing a lot of practice, kind of setting the groundwork for some different things. So here's our last one. Let's do one that will just, I'll put it in green so it'll make you feel better. X is greater than 0. And s approaches 0, sorry. And it is the tangent of 2x over x. And right now, you just wrote that up there. You looked over at the trig functions and you went, not good, not good at all. That's tangent. Tangent's not good. Tangent doesn't say sine, doesn't say cosine. This is where your idea of trig functions comes into play. Your trig functions allow you to, or your trig identities, or your all the different trig things you learned in either your trig class over the summer or your math analysis class. I can change this into sine and cosine. So let's do some algebra here. We're going to go left to right because this problem may take us a little longer. So we're going to clean up some algebra here. It's the same as this. I'm going to write it as x, and it's going to be the sine of 2x over the cosine of 2x. Tangent can be sine over cosine, so I can split it into that. All right, so I can put this over 1 as its fraction, so it kind of helps me clean things up a little bit. So let's go and work with it down here. So I'm going to go to another color. So step 3 will be, let's go with pink. So this is going to be equal to the limit as x approaches 0. And I'm going to do some algebra with it. And I've got the sine of 2x over cosine of 2x times 1 over x. All right, so I'm working my way through it here. Not looking good just yet. Kind of stressing me out. Okay, so now what do we think we're going to do from here? So let's just kind of separate this piece out. Sometimes it's good. You don't have to do it this way. If you can see it already, you're good. So I'm going to kind of separate this out. So we've got the limit of x approaches 0 of the sine of 2x over 1, and then I'm going to move this way. This is a little tight. I'll write it smaller because I got a feeling I'm going to run out of room. Oops, I'm going to move the x over here. Here we go. Okay, so did some rearranging for you guys. Took the x, put it under the sine of 2x, moved the cosine of 2x over here. So I split it. I can do that when it's multiplication. And this is the reason why. Look right here. I'm pretty close to this identity. If I get close to that identity, then I can change it to 1, and I have a strange feeling this may work. So let's look at this. How do I get, what do I add to this? So we're going to go to purple, the limit as x approaches 0 of the sine of 2x over 2x. So I added this 2. That means I got to add a 2 right there. Okay? And then I leave this at the end. So right here, I rearranged right here. I moved the x over and moved the cosine of 2x over, which is totally doable because it's multiplication. I was really close to the first identity. Since I got close to that identity, I added this 2 to create the same identity here. This becomes 1. So I'm on my final steps. Limit as x approaches 0 of 1 times 2 times 1 is 2 over the cosine of 2x. So it's sine of 2, this becomes 1. This 2 can multiply up there, so now I'm left with this. If I plug in 0 here, the cosine of 0 is 1, so therefore the limit is 2 over 1, which means it is 2. All right, so that's how we tackle trig functions. The key step is to create the identities so you can use them as a substitution piece. This one became 1. I was able to use some trigonometry to manipulate it. So yeah, this was a little bit longer of a problem, but that's our trig stuff for today. Good luck.